Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Engineering. So in this session, I am going to explain about the applications of superconductor. So the superconductors have a different application based on their extraordinary properties. So in this session, we are going to discuss about the cryotron and magnetic levitated train. So cryotron is a magnetically operated current switch. So it's working under the principle of property of material disappears when the applied magnetic field is greater than the critical magnetic field. So the superconducting property will disappear. So here we are considering the superconducting material A and B. So A is surrounded by the B. So here the critical magnetic field HCA of the material AB less than the critical magnetic field of HCB of the material B. So initially the temperature of the whole system should be maintained below the transition temperature of the two materials A and B. So here superconducting materials A and B plays the major role. So when the magnetic field produced by material B bypassing through the current, it exceeds the critical magnetic field of A. So the material A becomes a normal conductor, but B will not become a normal conductor at a critical magnetic field of A because HCB greater than HCA. So thus the current in the material A can be controlled by the current in the material B. So hence this is acts as a relay or a switching device. So another important application is nothing but magnetic levitated train. So we know that the superconducting material shows the Meissner effect. So due to this effect, superconducting material strongly repel the external magnets. So this leads to the levitation effect. So when a magnet is placed over a superconductor, it floats. So this phenomena is known as the magnetic levitation. So this principle is used in the magnetically levitated trains, that is super fast train. So magnetic levitated train, that is maglev train. So magnetic levitated train does not move over the rails, but it floats above the rails. So how it works means this train has superconducting magnets built into its base, an aluminium guideway above which the train will be set afloat by magnetic levitation. So the magnetic levitation is brought about by the enormous repulsion between two highly powerful magnets. So one produced by the superconducting magnet inside the train and the other by the electric current in the aluminium guideway. The current in the guideway produces the necessary magnetic field to levitate the train and helps in the propelling the train forward. So the other applications of the superconductors. So other than this, we have a different applications. So that is superconducting magnets that will act as an electrical machine. So electrical measuring instruments, power cables, switching devices, computer memory devices. So in superconducting magnets, so that will have act like a electromagnet. So the electrical machines, superconducting materials are used to manufacture small size electrical generators and transformers having high efficiency. So in electrical measuring instruments, so very small voltage can cause large constant current in the superconducting materials. They are used in the construction of very sensitive electrical measuring instrument such as galvanometers. So in power cables, superconducting materials are used in the transmission of power through the cable over long distances without any power loss or drop in voltage. Switching devices. Superconducting property of substance can be quickly destroyed by the application of magnetic field. So superconductors can be used in a switching devices and in computer memories also. So since the superconductors can maintain the current without any loss for a long duration. They are used for memory storage in computers. Thank you.